Hey Calc, PreCalc, soon to be Calc. It's really raining hard. You see out in the parking lot? No, not really. It is pouring though. I'll show you something prettier. I'll cover up my messy room with my old wrinkled hand. La-da! Pretty nice, huh? Mother's Day gift from my child. Okay, one of my children. Let's look at tonight before I go find something else to look at besides math till it's the end of the year. Alright, let us look at our topic for tonight. So, we've been talking about Cramer's rule, and before we can finish up with Cramer's rule, I have to teach you how to find a determinant for a 4x4. So let's get it in the screen even. Determinant for a 4x4 matrix. Alright, when we look at that, we are going to find it for this matrix. We'll call it A, and the straight line means that we're going to find the determinant. So we'll start with 1, -1, 0, 3, -2, 1, 2, 4, 3, 0, 0, 0, going by columns here, 0, 2, 3, 2. Straight lines means I want the determinant. Every square matrix, this is a 4x4, has a number associated with it called a determinant. I taught you how to do a 2x2 and a 3x3. So here we go with a 4x4. This method has a name, and we could have used it for a 3x3. We're going to be expanding by cofactors. And that is just the way to find a determinant. So, before we do that, we have to memorize a special map. Alright, this map, since this is a 4x4, there will be 4x4 places in this map. So the map will be plus, minus, plus, minus. And underneath of each of these, we're going to change it now. So under the plus, we'll have a minus, plus, minus, plus. And under that, we'll have a plus, minus, plus, minus. And under this, we'll have a minus, plus, minus, plus. So you have to memorize that map. And when we deal with, say, this entry, we'll be dealing with this sign. When we deal with this entry, we'll be dealing with this sign. So the relative spot in the matrix is designated by the corresponding sign in our special map. That map will not change. If it was a 5x5, it would follow the same pattern. But we're not doing 5x5s, we're doing 4x4s. So, to do this, to find the determinant by this method called expansion by cofactors, we are going to pick a row or column. I'm going to pick column 3 because it's very simple to work with because it has mostly zeros in it, and that you'll see that will be simplifying to our work. So, to find the determinant, we're going to use every member of the row or column that we've chosen. So I'll start with the 3. So I'm going to write down a 3. I'll try to keep that in the screen. Not that way. Come back, come back. Ah. Alright, just a minute. I can do this. Alright, so keeping that in the screen a little longer, I'm going to pick the 3 and put it here. And it's going to be associated with the corresponding sign in our map. So this spot was held by a plus, so we're going to get a +3. And then I'm going to multiply that, so I'll put a little dot for multiplication, times what's called the minor, and the minor is a smaller matrix that we are going to get from here by eliminating the row and column. So this is the row that 3 was in. So 3 was in this row and this column. So I'm going to eliminate that and write down the matrix, the minor, we call it, that remains. So eliminating these values and these values, what do I have left? Negative 1, 1, 2. Then I have 0, 2, 3. And then I have 3, 4, 2. Alright, so that's the first step. Then I'm going to add to that, I'm going to go down to the next member of my row or column I have chosen. Remember, I chose the third row. It's a 0. It is standing in the negative spot, so I'm going to connect the negative with it. Won't much matter because negative 0, it doesn't matter if it's negative or positive, and that will be followed by the determinant of the minor matrix, eliminating the row and column that is in. But since whatever determinant we get is going to be multiplied by 0, so I don't really care. And that's going to happen for this and this. So I'm just going to get plus 0 and plus 0. So the only thing for this one I have to calculate is this. So let me move let's move this plus sign out of the way and this bar. To find the determinant of the 3 by 3 like we did last night, we're going to repeat these values. So we repeat negative 1, 0, 3, 1, 2, 4. And let's get this out of the way. Alright, so if you recall, we do diagonals. The first diagonals that we're going to do will be the ones that will connect 3. Oops. I don't think that is correct. I'm not lining things up right. It should have been like that, and then like that, and then like that. So that'll be no fun to erase. Negative 1, 3, and 3. I was not lining that up well. Alright, let me get this back the way it should be. Negative 1, 1, 2, negative 1, 1, 0, 2, what was it here? A 3. Alright, let me line this up correctly. This diagonal, what was in this spot? It was a 3. Sorry. Alright, then this, then this. Alright, so along this diagonal we multiply and then we add from each branch, each arrow, and we keep the signs unchanged. So we have negative 1 times 2 times 2 gives me a negative 4. And this is a 1 times 3 times 3. And this is a 0. So together, the minus 4, the plus 9 gives me a 5. Alright, going this way is the way that I change the signs. 3 times 2 is 6. Times 2 is negative 12. It's 12, but I take the opposite. And this gives me a negative 12, so that gives me a positive 12. And this gives me a 0, so that whole thing zeroes out. And I combine whatever I get here and whatever I get here by addition. So 0 plus 5, I end up with 5. Now that's the determinant, but remember I have to multiply it by this, and that's the cofactor. This is the minor. So cofactor includes the sign from the checkerboard. So we have plus 3 times the determinant of this matrix, the minor matrix, so that gave us a 5. So 3 times 5 is 15. 15 is the answer. It's the determinant for that original matrix A. Alright, so what if you took the same problem? Let me just try this. I tried this and it didn't work. So I'm going to try it again on video. and see if you can help me figure it out. Let's do a determinant again. So just watch, and if I make a mistake, don't make the same mistake. Just do it correctly and show me tomorrow. This is the same problem. And say you weren't going to be intelligent about it. So you're going to pick a row or a column. So instead of intelligently picking this one, you're going to pick another one. So say that you pick this one, which isn't too bad because there's still a lot of zeros in it. But I just want to show you that you should get the same thing. And it doesn't matter what row or column, and it'll give us a little more practice with this expansion by cofactors. So we have the plus, minus, plus, minus, minus, plus, minus, plus, plus, minus, plus, minus, minus, plus, minus, plus. There's our little map. All right, so we're going to expand this by cofactors. So the first thing we're going to do is pick the row or column. This time I'm picking this one. So I grab this number first, 0, and the spot that it's in is a positive, but it won't matter. And then we're going to eliminate the row and column that 0 is in, and there'll be a minor matrix that we have to find the determinant for. But since it's 0, we don't care what number shows up here, because when we multiply it by 0, we get 0. Not so with the next entry. So we're going to pick the 2. Will it be a positive 2 or a minus 2? It is sitting in this position, so we've got a minus 2 going here. And it's followed by a matrix, and that matrix will be found. I'll switch to, this is fine, I haven't really done anything yet on this matrix. I'm going to eliminate the row and the column that 2 is in, and the matrix that remains is the one I need to find the determinant of. So 1, 3, 0, negative 1, 0, 2, and 3, 0, 2. Alright, so we'll come back and get the determinant of that. Then we hit a 0 again, so I'll just say plus 0. And then a 3. And what position, what sign will go with that 3? It's in this position. So we have another negative value. But what matrix, what minor matrix will we have? Well, we have to eliminate, I'll switch colors so you can try to see clearer. I'm going to eliminate the row and column in red, and what numbers remain when I do that? When I eliminate the row and column that this 3 is in, do you see the matrix that remains? This is not removed. 1, negative 2, 3, negative 1, 1, 0, and 3, 4, 0. So let me see if I can squeeze that on right here, and we'll figure it out below. So 1, negative 2, 3, negative 1, 1, 0, and 3, 4, 0. Okie dokie. Alright, so let me rewrite this, and I'll bring the minus 2 along for the ride. Hard to see with certain glare. Yeah. Alright, minus 2. Then I'm going to write this matrix. I'm going to recopy the first 2 columns as I do when I find a determinant for a 3 by 3. Recopying the first 2, 1 minus 1, 3, and 3, 0, 0. Alright, see if I can line these up right the first time. This diagonal gives me a 0. This diagonal, 3 times 2 times 3. So I get a 3 times 2 is 6 times 3 is 18. and the next one has zeros in it. So I get an 18 along here. Let's go back, 0 in that one, 0 in that one. This one is 2 times -1 times 3 gives me a -6, but I use a +6. So I take the +6 and the +18 and I add those together and I get a 24. And remember that is multiplied by this -2, so I get a -48 for this part right here. Alright, so now I'm going to work on this, and it's supposed to come out to 15. Mine did not. So I'll try it once here, and you can just tell me where I made my mistake. Alright, so this has a -3 in front of this matrix. So when I eliminate the row and column that was in, I had a -2. I can hardly see that. Where did all those numbers come from? Alright, I eliminated this row and that column in red. 1, -2, and 3. Sorry. 1, -2, and 3, -1, 1, and 0. I'm just double checking everything. 3, 4, and 0. Sorry, going kind of slow. Alright, so now I'm going to rewrite those columns. And I'm going to go diagonally. That gives me a 0. Plus a 0, plus a -12. So I get a -12 going those diagonals. Going backwards, I get a 9, which I write as a -9, 0, 0. So I get a -9. So I add the -9 and the -12, and I get a -21. So I have to multiply that by a -3, and I get a +63. And I add that to the -48 from here. This was -48, and this together came out to be the 63. So what's 63 and -48? Just working that out right here. 15. Okay, it worked for me this time. As you can see, the more intelligent choice was to choose the one we chose first, this column, because it had so many zeros in. We only had to do the cofactor expansion for one value, 3, and it gave us 15. But you can do it for any row or column, which is quite remarkable. So when I chose this row, I had to do zeros in 2 spots, but I had a 2 in the negative position, and then I had the minor matrices formed by eliminating the row and column that 2 was in, finding the determinant of that, multiplying it by the -3 gave me the 63. Similar work gave me a -48. Oh, that's right. So this is my work for this one. This gave me a -48. Then I did it with a -3, 3 being in the negative position. The minor matrix created by eliminating the row and column that was in. Left me with this matrix, which I found the determinant for, and multiplied it by the -3. And added these two together. They did give me 15. So you could do any row or column. So I just wanted to teach you how to find the determinant of a 4x4 matrix, which if we have time this year, we can do Cramer's rule for 4 equations and 4 unknowns. We've already done that with our back substitution and Gaussian elimination, but this is a different way. Alright, so that's it for tonight, and I will see you later. Bye.